Hello and welcome back to Psychology 301 Learning. This is Dr. Williams, and this is the second in our lecture series for Unit 4C2, Building a Better Critter, Stimulus Control, Extinction, and Aversive Control. And of course, we're focusing on aversive control, and today we're going to talk about avoidance. So let's stop. Before we start talking about theories, I'd really like to talk a little bit about the nature of avoidance and kind of a conundrum that occurs. That's kind of a confusing issue related to avoidance in particular. So my question is, how can something that ends in nothing be used to strengthen behavior? So I believe that avoidance challenges our understanding of extinction. Remember that in extinction, you have a previously reinforced behavior, and it's now followed by nothing. And the response occurs, and the consequence is that nothing happens. So the result is that behavior decreases or even stops. Now, in avoidance, behavior is also followed by nothing. The response occurs, the consequence is that nothing happens, and the result is that behavior is actually strengthened. And so there's got to be something else going on here. In both cases, avoidance and extinction both follow the same contingency. Behavior is followed by nothing. And in both cases, in extinction, the target behavior declines or stops, but with avoidance, the target behavior, the avoidance response in particular, actually gets stronger. It gets so much stronger that it will persist for days or for weeks. If you remember, there was one study where a dog that was trained to avoided successfully without ever making contact with the aversive stimulus over 650 times. So in some ways, avoidance contingencies violate what we know about extinction. So there has to be something more going on here. What exactly is avoidance? I mean, we talk about it being the prevention of an aversive stimulus, but how exactly, what do we mean by that? I mean, the actual procedure itself is that behavior is followed by nothing. So how is it that avoidance develops? How do we explain it behaviorally? It's very easy to say, well, you know that the shock is coming, and so you avoid so that it won't happen. But that makes an awful lot of assumptions and references to what the subject is thinking and what the subject knows. It's a very cognitive way of explaining the idea of avoidance. And so I'd like to look at a more behavioral explanation. What actually maintains the avoidance response after it's learned? So once we learn to avoid, what keeps it going? Why does it continue? And as part of that comes the question of, could you ever put the avoidance response on extinction? You know, to put a behavior on extinction, we remove the reinforcer. And there is no reinforcer following avoidance. Nothing happens. So there really is a bit of a challenge here to distinguish between extinction and avoidance and to better understand how avoidance actually works. So there are 5 major theories that deal with avoidance, that try to explain avoidance. And today I'm going to talk about 2 of them. I'm going to talk about 2-factor theory and 1-factor theory. And then next time we'll deal with safety signal hypothesis, the species-specific defense reaction approach, and the predatory eminence theory. So 2-factor theory is really old. It goes back to the 1940s. O. Hobart Maurer and Ralph Miller developed what they call the 2-factor theory of avoidance. And the 2 factors are really simple. It's classical conditioning followed by operant conditioning. So their idea was that with aversive conditioning, you have a CS plus. You have a signal, say a tone, that is paired with and predicts shock. So the classical conditioning part of this is that the CS plus, the tone, predicts shock, and through associative learning, that CS plus, that tone becomes aversive. Now clearly, the shock, the animal would like to terminate it and make it go away. But as through classical conditioning, as the CS plus becomes more and more aversive, as that tone becomes more and more of a warning signal and more aversive, you are more likely to see operant conditioning kick in. So the second factor is operant conditioning. And Maurer and Miller argued that the avoidance response is really just escape from the aversive CS. And that the what looks like an avoidance response is really just escaping a different aversive stimulus, and that it too is maintained through negative reinforcement, just like escape from the shock itself is. So it's not really the avoidance of shock that's maintaining avoidance. Rather, what's happening is that when you avoid by responding in the presence of the tone, when the rat responds to the tone, what they're really doing is escaping from an aversive tone or an aversive CS that acquired its aversiveness through classical conditioning. So really, according to this theory, there is no such thing as avoidance. There's really either escaping an aversive US or escaping an aversive CS. But in both cases, it's still escape. So here's the logic of this two-factor theory. The first factor is that the development of a conditioned response, which is fear. It's a classical conditioning process. The warning stimulus, in this case a light, is the CS, and the shock is the US. And so what happens, I'm going to use my little pen here. So you have a CS, which is the light, and it predicts, so the CS, the light, predicts shock. And so the conditioned stimulus is the light, and shock produces fear. Shock simply produces fear. But as classical conditioning continues, the CS plus slowly begins to create a conditioned response of fear to the light. So the idea is that the classical conditioning part of two-factor theory is that the CS acquires, the light acquires fear-producing abilities. Factor 2, now the subject can be negatively reinforced during this warning stimulus, during the CS. So this is the second part. This is the operant conditioning part, where you have an aversive CS is presented, and there's a response that removes that aversive CS, turns that light off, and that reduces fear, which strengthens the behavior. So two-factor theory is really, it reduces avoidance learning to escape learning. It just says that the organism learns to escape from the CS and the fear that the CS produces. As fear increases, you should see an increase in response rates. The more afraid of the CS they become, the more they should respond. So there should be a positive correlation between fear of the CS and avoidance behavior. So then the question becomes, well, what really happens? Well, if you watch rats learning to avoid, they do show fear during the escape training. During escape training, they show fear. There's no question. They don't like the shock. It's very aversive to them. And as they start to learn that the tone is paired with shock, they start to show fear of the tone, and they rush over and they respond. However, with extended training to where they get really good at the avoidance response, we start to see a change in behavior. First of all, the classic fear response for rats is freezing. And they freeze when the US comes on, and during the early stages of avoidance learning, they freeze when the tone comes on. But with extended training, they show less and less freezing, and they show more exploration and more grooming in the absence of the CS plus. So when the CS plus isn't on, they look very comfortable. They're not doing second order conditioning and fearing the chamber, for example. And in fact, when the CS comes on, they usually don't pay attention to the CS until the end of the CS interval. So if the CS is on for 10 seconds, they don't really pay attention to it until the last couple of seconds. And in fact, their avoidance responses almost reliably begin to occur only at the very end of the CS plus signal. So the level of fear appears to decrease with extended training. So in 1963, Leon Kamen and some of his students did a conditioned fear and avoidance study designed to assess the level of fear of the CS that rats have following avoidance training. So in phase 1, there was operant training, operant conditioning. There are 4 groups of rats. They're trained to press a lever for food. It's pretty simple. It's just an operant response. It gives us something to measure. This is going to be one of those condition suppression behavior studies. So we're going to look at how much we can suppress lever pressing for food. So they learn to press a lever for food, and that's how they earn their food every day, and they do this for maybe a month. In phase 2, they're taken at a different time of day by a different lab assistant to a different room where they receive discrete trials shuttle avoidance training. So they're put into a shuttle avoidance chamber, and a CS comes on right before shock is delivered, and the avoidance response is to run from the shock chamber to the safe chamber. It's pretty simple. And so they do this training until the rats in each of 4 groups avoid shock by responding during the tone or during the CS. So group 1 is trained until they avoid 1 shock. Group 2 is trained until they avoid 3 shocks. Group 3 is trained until they avoid 9 shocks. And group 4 receives extended training, and they are trained until they avoid 27 times in a row, consecutively. And then they're tested with a condition suppression procedure in the operant chamber. So remember that when we do that, what we do is we put them in the operant chamber and we turn on the CS from the shuttle training. So this is a shuttle chamber. You can see that there's a safe chamber and a shock chamber. And so the idea is that the light or the tone comes on, warning about shock. And then, actually, I think this is the shock chamber. So the light comes on, and they have to run through the little hole to the other chamber that's safe. Pretty simple. So the only difference between our groups is how many times they're allowed to avoid. And these are the results from the Kamen, Brimmer, and Black study. And it's pretty interesting. What they're basically measuring is the degree of suppression of lever pressing for food, and that's used as an index of fear. So with just classical CSUS pairings, so they just get classical conditioning, you see that they show a decrease in responding across the board. But when training this conditioned relationship between the light or the tone and shock using an avoidance procedure, we see that the condition suppression changes. So as training, this is no suppression. So with 1 training trial, this is 1, 3, 9, and 27 avoidance trials. With 1 avoidance trial, you get a little bit of suppression. The same is true for 3. And as they move out to the group that has 9, you see that there's a great deal of suppression using the classical conditioning procedure. And with avoidance, you get much less. And then at 27, we see that the avoidance trials, 27 consecutive avoidance trials, when tested using a CER procedure, show almost no fear. They actually show less fear than the rats that only avoided once. So they're showing very little suppression, which translates to they're not afraid of the light. They're not afraid of the CS. So these data are a serious problem for two-factor theory because two-factor theory hinges heavily on the idea of conditioned fear. And here we clearly have no conditioned fear. Now there's another problem for two-factor theory, and that's the rules of extinction. So if we define extinction in classical conditioning, what we really are talking about is unpairing the CS plus from the US. And you basically lose associative strength, and you have less power over behavior by the CS. Once the avoidance response has been mastered, the CS and the US are unpaired. Once they are avoiding by responding during the tone, during the CS, they don't experience shock. They don't experience the aversive stimulus. So what would you predict? Based on the definition of extinction, you should expect the avoidance response to go into extinction. They should, when there's no longer, when there's no shock anymore, and they're not escaping shock, then they should go into extinction, and the avoidance response should disappear. It should. So in theory, they should learn and unlearn the avoidance response, kind of the way pigeons learn to peck and not to peck during negative auto maintenance. But what really happens is that you get extinction of avoidance responding is extremely slow. As I mentioned previously, the avoidance responses can be very persistent. One dog in an earlier study continued with the avoidance response across 650 trials after only being shocked a few times at the beginning, and then after that they were never shocked, and yet the behavior never went away. Furthermore, when CS1, so CS1 plus, is predicted by a second signal, CS2, that stimulus should become aversive too, kind of like second order conditioning. And the avoidance response should happen even sooner. Why wait around for CS1 if you can respond during CS2 and prevent CS1, which according to this theory is supposed to be aversive? But that doesn't happen. The critters wait through CS2, and they wait all the way through CS1 until the very, very end, and then at the very last minute, they respond. So that's kind of interesting. It clearly suggests that fear is not what's operating here. So two-factor theory simply isn't viable. And at the time, it was replaced with the idea of negative reinforcement, that one-factor theory is just negative reinforcement is sufficient to maintain the avoidance response. And there were lots of studies that were consistent with this. Murray-Sidman showed that you don't even need a signal. He had unsignaled fixed interval shocks. So they were shocks delivered every, say, 30 seconds on a fixed interval. And when he did that, the rats ran before the shock was delivered. They learned to run. And Herrnstein and Heinlein criticized Sidman by saying, well, they're using the unsignaled fixed interval. They're just using the passage of time as a CS. So they did it with variable intervals. So now the shock is coming at variable intervals, and the rats still run before the shock is delivered. So this slow extinction, this absence of a decline in avoidance responses, they claimed was simply a failure to discriminate a change in the contingencies. Now, at the time, that's all that was offered as an alternative to two-factor theory. But since then, a number of people have been unsatisfied by that because it really doesn't answer the questions of what is operating. It simply is stating that it's assuming that there's a failure to discriminate, a change in the contingencies, and that's why we get this persistence. So I'm going to stop here. That's good to talk about one and two-factor theory. Ultimately, the theories that I'm going to present next are much more satisfying and much more descriptive. So we'll meet in our next lecture to talk about the safety signal hypothesis. All right, have a good afternoon.